So we have this theorem that says the sum and product of the roots of a quadratic function gives us these two properties. So the sum of the roots is going to equal negative b over a. So if r1 is the first root and r2 is the second root, when we add those together, it gives us an expression that's equal to negative b over a. And then the product of the roots, r1 times r2, is going to be equal to c over a. Gives us an expression so that we can find c and a and b in this particular expression when f of x, or when our function is a quadratic. So let's go through the proof quickly. First thing is we always want to start off with a let statement, just a reminder. So we let f of x be a quadratic function. We also let our roots, or r1 and r2, we define our roots. So what we need to do now is tell where or in what situation we can find roots. So we know that we can find roots when we set this thing equal to 0. So 0 equals ax squared plus bx plus c. By the quadratic function, or quadratic formula, we have our defined roots r1 and r2. We know that r1 is equal to negative b plus square root of b squared minus 4ac over 2a. And r2 we can find by looking at the negative version. So negative b minus b squared minus 4ac over 2a. So what we need to show is that this property holds for any two roots of a quadratic. So let's go ahead and check that out. So this portion, we're going to look at the sum. So r1 plus r2, we're going to take these two expressions and add them together. So negative b plus b squared minus 4ac over 2a plus negative b minus b squared minus 4ac over 2a. Nice and easy here. We've got a common denominator already, so we can combine our two numerators. So let's go ahead and do that. Combine our two numerators, and that's all over 2a. And now we want to combine like terms. So we've got a couple b terms, and these are negative b terms. So we've got negative 2b. And then these two guys right here actually cancel because we have a positive version and a negative version, leaving us with negative 2b in the numerator and 2a in the denominator. And we cancel these like terms, or these 2's here, and we end up with negative b over a, and that works. Next piece we want to look at is the product of the two. So looking at the product, we've got r1 times r2, so our first root times our second root. And again, we're just going to write these out. We know we define these as the two roots and by the quadratic formula. We can rewrite these two roots, so positive in the negative version. So the next step is we just want to expand these two things. We want to multiply our numerators. And in order to do that, we're going to have to FOIL. So negative b times negative b is going to give us a positive b squared. Negative b times that expression is going to give us a positive b times b squared minus, root b squared minus 4ac. And then these two here, we've got positive version here, so we've got a positive b times root b squared. Sorry, that's a negative. Minus b squared minus 4ac. And then lastly, we want to multiply these two things together, and that's going to be negative b squared minus 4ac squared. And that's a square root, so we just drop the square root in this particular case. And that's all over 4a squared. Next step here is to simplify. So let's look at what we have up top. Up top we have a negative b squared when we distribute this negative, and a positive 4ac. So we're going to end up with positive b squared and a negative b squared. So that drops off. We've got a positive b times the quantity root b squared minus 4ac, and a negative b times that quantity. So that drops off. And what we're left with is just this term at the end, 4ac over 4a squared. Simplifying that, the 4a's cancel, and we're left with c over a, which is exactly what we're looking for. So our proofs always end with conclusion. So therefore, when R1 and R2 are roots of f of x equal to ax squared plus bx plus c, R1 plus R2 is equal to negative b over a, and R1 times R2 is equal to c over a, and we're done.